I am recording, so. So the question is, well, here's a histogram. Oh, yeah, we need the light. Do you think that that histogram represents that data well?
No.
Have you just said no immediately because you think it's going to be a no?
Because I know they can be, but like
You can't
like
really.
it could be better. I don't know.
I feel like it could be.
It could be less like
Yeah.
jumbled up.
No, I think that's a good one.
How?
Well, let's look at it. It's a histogram. What's a histogram supposed to do? Represent data and show what?
Frequency.
Frequency. Can you give it me in words that you would have understood before you even knew about the word frequency? What does the height of the bar tell you?
About number of
So in this case, I've got weight. Make something up.
Wait, elephant.
no,
Oh, it's too small.
number
Dogs.
of rats that way.
So the number of rats. Wow. Okay, it's only grams. 30. Yeah, it could be right. Mice and rats. This would be the number of rats that weigh between 0 and 30. Okay. So there's 10 of those, and this is the number of rats that weigh between 30 and 40. So it doesn't do its job.
Yeah.
Okay. So, so you're actually saying it is fine. There's no problem. Although you all immediately went, no! You actually should be now going, yeah, it's fine.
No,
It is.
You think it's fine.
I don't think it's good.
You don't think it's. Why is it not good?
Well, I don't actually know why. I just feel like you're tricking us.
I'm not tricking you. Definitely not.
I think it represents well because it's doing its job. But why would I just don't understand why they would record a 0 to 30 group and then like a 40 to 45 group.
Those are all the same number.
Yeah, the groups aren't like.
So the group's different widths, yeah? So why, for instance, would we have this tiny
Yeah.
little bar? And why have we got really big fat ones at the end? No?
Got really big fat ones because for each of those groups it was just the same amount of rats, and they just lumped them all together as one big bar.
Okay, so we plumped them all together. Whether it's the same amount of rats is debatable. We don't know that. But the clumping together for a reason is something that we should carry on. Sorry?
Is for the skinny ones, is it for them like the ones that are closer to 60? Is it because the high ones don't want? It's because it's more specific, so it shows that, because if you put them both together, it would be the highest frequency, but it shows that more of the high numbers are towards the other one.
Excuse me. Yeah, you're going down a better route now, aren't you? So there's more detail in this little bit. Why do we think we want more detail here? Sam, what are you going to say?
Oh, I was also going to say that could it be the change of height? So if they're the same measurement, they'll be in like.
So you think we've clumped them together? Well, that's basically what Malin said. If they're the same number, they've just drawn them as one big bar.
Yeah, the other thing is, but if they're
So let me ask you then, if these three groups, let's say there were three groups, are all the same number, how many is in each group? So 10 shared between three groups is 3. Yeah, we can't have 3 1/3 of a rat. So they can't have been all the same height,
Yeah.
can they? Can't have been all the same height. Yeah.
Maybe it was. Oh, actually, never mind.
I think Zuri said something also very interesting. What if we went from 55 to the 60 group and just put them together?
Wait.
What would the bar do? So all these three would go together and would build on top of each other, right? It'd be a really tall bar. Yeah. So why I think Zoe's right with the making it smaller because we want more detail. So why have we made it bigger at the ends? We think of the opposite of that. Okay, sort of irrelevant. Why? If you think about all the other stuff that we've talked about, what is these two ends? The extremes, yeah. And what normally happens in the extreme ends of data in terms of frequency? Less frequency, right? We've got less frequency. So what does this 10 mean? It means that there are 10 rats that are anywhere between 0 and 30. But up here, look, we've got 15 rats that are really concentrated into a tiny little group. Okay? So we've got all this information. Now, actually then, what about the comparison of this group with this group that's actually lower then? So this first 0 to 30 group and then the 30 to 40. What would you say? They're less rats? Yeah? Right, so again, what is a histogram or any bar chart or any chart supposed to do?
Represent data.
Show data, represent data, but also there's that other word. Well and?
Clearly.
Clearly, thank you, you got the L in there this time. Clearly, now, what I would say is, does this graph, so what we want to do with charts and graphs is I want to be able to look at it very quickly and make a snapshot decision without having to actually analyse the data, because the person that did the chart should have done the analysis. All right? I need to be able to look at it and interpret it, but it should be quite easy. So, these big groups at the end here kind of dominate things, don't they? Because they're big, chunky bars. When you looked at it, which were the first groups you'd notice? The big ones, yeah? And then where was your eye drawn next? To the middle, to these ones. Now really, our eyes should be drawn where first? The middle, okay? So, because we've clumped groups together, now we've got a reason for clumping groups together. Why did we say? Sort of the extremes, and what normally happens in the extremes? Less data, so we might have a couple of small bars and then a 0. Who had a 0 bar in any of their data?
Well, it wasn't a bar, but I had
A group.
a 0.
Yeah. You had a 0, and we talked about if you'd had slightly bigger groups. Yeah. Right? So maybe there was some small, maybe there was a 4 and a 3, and you know, some small ones that are kind of bobbly but irrelevant. So you can kind of clump those together, because I don't really care how many rats are between 0 and 30. These guys, I mean, if this is the normal weight of a rat, this is a big fat rat, but there's not that many of them. We're really interested in this middle group. So what we need to do is we need to adjust how we do our histogram and make it look a little bit better in terms of how it represents the data. Does that make sense? So what we do is we're going to move away from this frequency, and I've already told you what we're going to move to, and some people are reading it, what we're going to move to.
Density.
Frequency density. So you will see this on one of the pages, page 203. Okay? We're on page 203. So this time what we're going to do is, instead of the bar height representing how many's in the group, we're going to change it so that the area of each bar, the area represents how many. Alright? So therefore, if I take you back to if I take you back to the other picture, right? What would happen if this width is set in stone, but I said, right, the area of the bar needs to represent 10. What's going to happen to it? Pardon? Well, what's just going to happen to the size of the bar relative? So this one has got to be up to 20. This bar has got to have an area of 20, and its width is only how big?
We would have to get
5.
smaller.
So it's 5, and it's going to have to go up to 4. All right? So it's still going to be quite high, whereas this one has a width of 30, but its height is only going to be
0.3.
0.3 to get 10. Is it 30 times 0.3 is 10?
No.
You should be able to check that easy, because it does confuse 30 times 0.3.
It's
Is
It's not.
How could I do it then? So the area is 10, I've got to do 10 divided by 30 to tell me the height, haven't I? Area of a rectangle.
3.3.
If I know the area, so what's 10 divided by 30?
3.33.
1 over 3, 1/3, which is 0.333.
Right.
Okay? So comparatively then, this bar height is still going to be quite high at 4, but this bar is only going to be a third high. So it's going to look nowhere near, so it's going to be really quite low and skinny. So proportionally, it's going to be a better representation. So that's what we're going to be doing. And that basically is it. All right? That's all we need to know. So frequency density, the area of each bar is equal to the frequency. The frequency density is plotted on the vertical axis. So frequency density is worked out by doing frequency divided by its class width.
Should we title this frequency density?
Yeah, so we're doing, actually what it's called is histograms with, or frequency density histograms, or you can also say histograms with different class intervals. So, write down the important things from this. It's page 203. But write down the pink boxes, and then we'll move on. So we've got this frequency table in front of us. So it's the first question in practice 5. What page is that?
204.
204. So page 204. Okay, right, what we're going to do then is let's just go through the process. Don't need a musical background. Right, so we've got the lengths in centimetres of some horned vipers are recording in the table. So we've got a length of somewhere. Do you notice, look, where the and equal to is? So on the other side, so we were talking about that. Why is that? Because we had a minimum that were recorded, and the maximum, well, we didn't actually reach 72, but that's what they decided. Are the class interval, the class widths, the same?
No.
Obviously not, because we're doing it in this section. So this one has a class width of 10, so 45 to 55. What's the class width of the next one? 5. Next one? Next one? Okay. Why do you think it's done as a 10, 5, 5, and 7?
Because
Yeah.
the bridges center groups 55 to 60 and 60 to 65. Those are the middle 50%. So we're not middle 50.
No, they're not. I mean, they're not specifically the 50%, but they are. We would expect, by the look of it, look what the frequencies are. The highest frequencies are at this end. Where's the least amount of frequency? So where will this data have come from, by the way? Let's not forget. Where did it go from and to get to this stage, the data? What did someone do? Collected what kind of data? Raw data. They collected their raw data, right? And they probably went through and just counted a load of snakes and recorded their lengths. And then what they wanted to do was, well, we don't want to look at them all individually. I'm going to group them. So they decided their groups based on the raw data they had. It was decided by the person that collected the data, all right? or the person that then wanted to analyse the data. So it's not just a random thing that, oh, why is that group like that? It's like they chose it because they knew they had a lot less of the smaller snakes. All right? So they decided to make these ones bigger. And then this final group, why do you think this one, even though it's quite high, was just slightly bigger? What do you think the reason is there? Yeah.
There was an outlier that made it stretch.
Yeah, it might have just been a couple more at the bigger ends that wasn't worth making another group. All right? So we had a group, if we did 65 to 70, all right, there might have only been one snake that was in a 70 plus group, so we might as well clump it in with the other group, all right? Especially because it's not the biggest group anyway. Does that make sense why it was done? So let's have a look then at the frequency density, because as soon as we've got different class sizes, we've got to do frequency density, not frequency. So how do we do it then? So we've got the class width multiplied by 1.3 has to equal 30. So 20 has to equal 5 multiplied by 4. 26 is 5 multiplied by... Yeah, 5.2. And 19 equals 7 multiplied by... So we do 19 divided by 7.
2.71, and then it goes on a bunch.
2.7. Should we leave it at 2.7?
The next one's 1 after that.
Why? Okay, so 2.7 is enough. Let's leave it 2.7. Would it make sense to go to another decimal place?
No.
Not in this case. And what would it have? What impact would it have on us if we did go to a second decimal place?
We would have to make the grid lines.
Yeah, exactly.
more
Our graph would have to be, I like it, more accurate. We'd have to have a lot smaller grid lines available, or we make our graph bigger to cope with it, right? There's no point adding an extra layer of accuracy if we can't graph that accuracy. So now the question is, how do we graph that? Well, actually, it's much the same as we did before, only we use frequency density instead of frequency. Okay? So what I'm going to get you to do, since we've got 20 minutes, I would like you, so we've copied and completed the table, I'm going to construct a frequency density, but what I would like you to do actually is do two. I want you to do the same thing once using the frequency and once using the frequency density, and then we can have a look at what they look like side by side. Does that make sense? So you can see the difference between using frequency and frequency density. And just one thing, because some of you don't really get perked up until I say things like, in an exam, how am I going to get better in an exam? In an exam, this is one of the biggest mistakes where people lose marks, because they just draw a frequency histogram and they don't do frequency density. All right, and it's just no marks, you know, because you haven't done the appropriate thing. So for those of you, it's all about exams. This is how they try and catch you out. Okay, clear? So draw two histograms, one using frequency, so so this is going to be the x-axis, all right, x. This one will be the y-axis on the first one, and this one will be the y-axis on the second graph, okay? So draw two for me. You have to pick it up. Don't worry about colouring it in or anything until you've drawn both. We're looking at shapes. Please use pencils and rulers.